The sodium-potassium pump is an active transport mechanism that is driven by the breakdown of ATP and works through a series of conformational changes in a transmembrane protein. 3 sodium ions bind to the cytoplasmic side of the protein, causing the protein to change its conformation. In its new conformation, the molecule becomes phosphorylated at the expense of a molecule of ATP. The phosphorylation induces a second conformational change that translocates the 3 sodium ions across the membrane. In this new conformation, the protein has a low affinity for sodium ions, and the 3 bound sodium ions dissociate from the protein and diffuse into the extracellular fluid. The new conformation has a high affinity for potassium ions, 2 of which bind to the extracellular side of the protein. The bound phosphate now dissociates and the protein reverts to its original conformation, exposing the 2 potassium ions to the cytoplasm on the inside of the cell. This conformation has a low affinity for potassium ions, so the 2 bound potassium ions dissociate from the protein and diffuse into the interior of the cell.